this video, I'd like to share with you a number of different examples in the openOchem homework system. So I've created this openOchem demo quiz, if you will. So I'm going to open it up as a student. Here I will attempt the activity. Now, because it's a homework exercise, I can keep on trying these activities until finally I get them all correct. And I can leave the homework and come back, that sort of thing. If it's a quiz, you must attempt and then finish the quiz. So again, homework, I can keep on trying until I finally get the final set of answers. So this particular homework setup has 8 questions. And I'm going to start with the first question. So right here it says, rewrite the following using the bond line structure. Now the other thing is, the purpose of this video is really just to show you a variety of different kinds of questions and how to use the draw editor, that sort of thing. I'm not teaching the organic chemistry in this particular video. That will come later. So here I see I've got a CH3COH+. Okay, I've got a formal charge, I've got another carbon, and then 2 CH3 groups. In fact, what I might do is put the 2 CH3 groups that are on the end there. And those 2 CH3s, this is the CH, and that CH would be attached to another carbon. And that carbon would be making a bond to an oxygen. So note, I can select oxygen and nitrogen and hydrogen, those more commonly used elements, just right here. But if I need to select a different element, I can click on the atom tool. And I'm just using this as an example. Can open up, and if I had to add a chlorine, for instance, I can do that. But of course, that's not what I want to do. I want to put an oxygen at the top here. And let's see. So this takes care of the COH, and then I've got the CH3. Now, how is it that this oxygen has a positive formal charge? Really, the only way that that can happen is if this is a double bond. And now I'm going to use the formal charge tool like this. Okay, so I've just drawn the bond line. Drawing, I check I've got 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So I'll check my response here, and indeed I have it correct. Often I'll try to give a little bit of feedback, some hints, that sort of thing. Now let's look at question number 2. In this particular case, you're asked to show the formal charges after you redraw the structure. So this is an opportunity to show you the ring draw tool. So here I come, I need a 5-membered ring. I'm now going to go back to the plus here, which allows me to draw these different kinds of bonds. So I'm going to draw a single bond. I'll start off with a methyl group, but I'll put an oxygen on the end. Now note, this is not an OH, it's just an oxygen. And we understand that all the atoms have an octet, so it must be that there are 3 lone pairs of electrons around that oxygen. And the only way that this can happen is if the oxygen has a formal charge. Now I just put a positive formal charge. Really what I want is a negative, so click that and click that again. So I believe this is what I'm looking for. I check my response, and indeed, correct answer. Let's look at number 3 here. Okay, so this is a different kind of question. We're using the Marquet tool, which is the tool up here, and we're looking for all the chiral centers. This is a molecule of colchicine, or a structure representation of colchicine. So I scan through and I see actually there's only one chiral carbon. It's right here. So I would select that. But let's just say, for instance, this carbon right next door is also chiral. So the idea is that I would click on the shift button and then click this as well. And then that selects another carbon. And let's say the next one was also chiral. So then I'd be selecting these. Now, actually, I'm going to check the response. I know this is incorrect. All right, so it's wrong. So the beauty of the homework system is what I can do then is now select the Marquet tool, click this. That is now going to be the correct answer. Check response. So you can keep on trying until you get the correct response. Let's look at question number 4. So one of the beauties of openOchem is not only does it assess structures, it also assesses your curved arrow notation. We use curved arrow notation for looking at resonance forms. So in this particular case, we're looking at how is it that the electrons are delocalized. And as I say, we use the curved arrow notation. So in this first case, what I'm going to do is I've selected here this double arrow, or double-headed arrow for the resonance. I put my mouse over the pi bond because that's where the arrow is going to start. and then I'm holding down on my left mouse, if you will, or the left click of the mouse, and I point to the bond next door. So I'm not pointing at the positive charge. By convention, that's not correct in showing resonance forms. So I point right here. Okay, and that would allow me to look at this particular resonance form where now the positive charge is found on this carbon. And then for the next resonance form, and using curved arrow notation, I start from the lone pair, and again I point in between the oxygen and carbon bond. Now, as it turns out, openOchem, in terms of curved arrows, is not able to completely exclude if you start the curved arrow from an atom. But I'll usually be providing the lone pairs, and as you know, that is the better way, or the preferred way of showing the curved arrow notation. So now let me check the response. Indeed, we have that correct. Let's look at number 5. So here we're translating a chair conformation to a planar ring. So again, this allows me to put in the 6-membered ring. Now I notice that I've got an O, and Me stands for CH3. And so one of the reasons why I chose this as an example was to show you the idea of, okay, I want to draw a bond, but not just any bond. And if I'm looking from the top of the ring, then this OCH3 would be going away. So I'm going to put this in here. I'm going to add in the CH3 group right here, and then change this carbon to an oxygen. And of course, this is going to be going away. I have an oxygen right next door, so that's that one. And then I have a CH2 group and another oxygen, and that's an OH like this. Now in this particular case, as we will find out when we study chair conformations, this bond here is actually above the plane of the ring. And so I'm going to do this, and then 2 carbons over. Again, this OH group is above the plane of the ring. And so we'll put those in. So again, I realize that the chemistry may not be solid for you just yet, but I'm just showing you how to use the draw tool. It's really handy to have the carbon, hydrogen, nitrogen, oxygen right here, as these are the more common elements that we use in the draw editor. And so let's check the response, and we did that correct. So that's great. Keep up the good work. Now let's look at number 6. This question illustrates one of the features in openOchem that you're not likely to find in other homework systems. It actually allows us to draw a Newman projection based on this template. We're going to draw the Newman projection for 1,2-dibromoethane corresponding to the energy that this conformer would have at position B. Now this is relatively high energy, so the idea is that it would be therefore in the eclipsed conformation. So there we go there. And the idea is that you drag atoms as such. And I know, for instance, that there would be 2 hydrogens eclipsed. We'd have a bromo in the back, and we'd have a bromo in the front, in terms of back carbon and front carbon, except they're not going to overlap with one another. Rather, the bromo would overlap with a hydrogen, and the bromo would overlap with another hydrogen. And so if I now check the answer, I should hopefully get the correct answer. Indeed, I do. So I just wanted to show you this, so when you meet it again later in the course, you'll have a sense of how to complete the template. Let's look at question number 7. In question number 7, we're comparing a series of molecules to decide which one would have the largest dipole moment. Now, this question could have been posed as a multiple choice question, but instead I've drawn the 4 molecules here, and we're going to use the Marquee tool. So this right here. So if I leave the mouse on top, we see the Marquee select. And the idea is that I'm going to select the molecule that has the largest dipole moment. Now you can see that each molecule has the heteroatom involving the halogens. And so essentially we're looking for that molecule that has the halogens with the biggest difference in electronegativity. So actually it's going to be this one on the end here. So selecting the Marquee tool, and then dragging and selecting the entire molecule, and then indeed check the response. I have some feedback here for you. So as I've mentioned, many of the questions will have feedback in guiding you why the answer is correct, and in some cases why the answer is incorrect. And finally, again, a feature of openOchem is that we have some of these JS mold type questions, which actually allows us to look at molecules in 3 dimensions. In this case, we're to draw the most stable conformer for 1,3-dichlorocyclohexane. But before we get to the cyclohexane, I just want to show you that we can build up the molecule here. So I've selected carbon, and then I'm going to change this hydrogen to a carbon. So we extend the chain. I'm going to extend it a little bit longer. And then with these tools over here, I'm going to click this guy. And now I can translate the molecule. In other words, I can move it like this. If I double click on this screen, I can rotate the molecule so we can see a little bit better. We can also enlarge so we can see the molecule in a better fashion. One of the other great features of the openOchem is that it allows us to do something else. And that is if I select this tool and then click on one of the bonds, for instance, this one, I can actually rotate the bond. And this allows us to look at, again, different conformers with different levels of stability. I've yet to see a 3-dimensional tool that allows you to do that, except for the one here in openOchem. But anyways, that's a sidetrack. We want to draw 1,3-dichlorocyclohexane. So I'm going to choose the ring here. I'm going to choose the 6-membered ring. And I am, with this icon selected, I'm going to double click so I can rotate the molecule a bit so you can see indeed that this molecule is in the chair conformation. Again, something that we'll be discussing in class. I'm going to be drawing chlorines on carbons 1 and 3. Now, right now, all the carbons are identical. So let's say this is carbon 1 and this is carbon 3. The more stable conformer will have the chloro groups in the equatorial position. So that's, in a sense, the midpoint of the ring rather than pointing down or pointing up on the ring. So I'm going to now choose my bond tool here, or my atom tool, choose the chlorine, click here, click here. So now the 2 chloro groups are in the equatorial position. This should be the more stable conformer. So let's check our answer, and indeed we're now complete. To finish this assignment, you would click Submit All, although if you wait long enough, it would automatically save, and then you can see that your result is complete in your homework system. So hopefully this video has helped you see the different question types in openOchem and also see how to use the draw editor under different situations.